Good day and selamat sejahtera to all panelists, Dr. Jeffrey, Dr. Shariza, and Dr. Chan Xiang. My name is Tan Junyu. Today I present my PSM with title Determination of Ionic Conductivity of Polyvinyl Alcohol-based gel polymer electrolyte containing a plasticizer for supercapacitor application. My supervisor for this project is Professor Ashadi. First, I will talk about my PSM1 project outline. For Chapter 1 introduction, it includes research background, problem statement, objective, scope, significance of research, organization of thesis, and summary. For my Chapter 2 literature review, there's 4 main topics. First is supercapacitor, the second is polymer electrolytes, the third is characterization techniques, and the last is electrochemical performance test. For Chapter 3 methodology, it will start with materials and chemicals. After that is preparation of electrolytes and electrodes. After that is characterization of electrolyte, then is characterization of electrode, and moreover, fabrication of supercapacitor from electrode and electrolytes. The last step is electrochemical performance analysis. The next slide is talking about a briefly introduction of this project. The world is facing energy crisis due to the overwhelming of fossil fuel usage causes pollution and catastrophe of environment. Green energy can solve this problem, but sun is not always shining. This causes the green energy has ability usage problems. So the best solution is using energy storage mechanism. Supercapacitor is one of the energy storage mechanism with efficient power performance and long-term cycling stability. The main element in fabrication of supercapacitor is electrolytes. Ionic quantity of electrolyte decide electrochemical performance of the supercapacitor. Next is problem statement of this project. The first problem statement is that weakness of liquid electrolyte, which are toxicity, high expenditure for packaging the material, and leakage problem which will lead to serious risk of fire. The second problem statement is that solid electrolyte has low ionic conductivity and causing low performance if applied on supercapacitors. The reasons of low ionic conductivity property is due to the crystalline phase of solid electrolytes restrict ion movements. Next, there is 3 objectives for this project. Objective 1, to analyze the ionic conductivity of polyvinyl alcohol-based gel polymer electrolyte containing plasticizer. For objective 2, to characterize the morphological and structural properties of reduced graphene oxide electrode by using techniques such as SEM, Raman, and XRD. For objective 3, to investigate the electrochemical performance of RGO supercapacitor with PBA-based gel polymer electrolyte by using CV and charge-discharge analysis. Next is scope of this project. The research will focus mainly on ionic conductivity of supercapacitor electrolytes and characterize the electrodes by EIS. The supercapacitor electrode will be prepared and characterized by scanning electron microscopy (SEM) for morphological analysis, XRD and Raman spectroscopy for structural analysis. The third scope is the electrochemical performance of supercapacitor will be studied by using CV and galvanic charge-discharge tests only. The next slide is literature review. The first finding is ionic conductivity of gel electrolytes with and without plasticizer EIS by Shari F 2016. As we can see from upper image is ionic conductivity versus frequency graph. The first graph is ammonium thiocyanide gel polymer electrolytes without plasticizer. The second one is with plasticizer. As we can see, the results show that the gel polymer electrolytes without the plasticizer have the lowest ionic conductivity of 0.09, but the gel polymer electrolytes with plasticizer has the highest ionic conductivity of 0.0156. The next findings is morphological structure of reduced graphene oxide by SEM, and this one is from Tan M 2020. As we can see from the lower side of the image, this is the SEM image of RGO. There's a flumps of flags in the SEM image, and there is some wrinkles on the structure of the SEM image. It has been reported that the wrinkles in the structure of graphene sheet enhance its charge accumulation capability. The next finding is structural analysis of reduced graphene oxide Raman spectroscopy by Khan M 2020. As we can see, the G band has 1583 Raman shift, and the D band has 1350 Raman shift. And this two peaks is formed due to a disorder in the structure of graphene. The ratio of the two peaks is calculated as 0.87. For the next finding is structural analysis of reduced graphene oxide XRD from Salim Hibbs 2018. As we can see from the lower image, there are 2 XRD patterns. The first is from graphene oxide and the second is reduced graphene oxide. In this research, graphene oxide is formed to reduce graphene oxide by thermal reductions. As we can see at the first XRD pattern, graphene oxide, the peak is at 001 with 11.8 degree, and it formed the crystal structure. After the heat reduction, thermal reduction, there is also a peak formed at the reduced graphene oxide XRD, which shift to 002, which is 25.5 degree. It also shows that there is a crystal structure formed after the thermal reduction. The next finding is CV curve of supercapacitor from polymer gel electrolytes CV test from Alipori S 2019. As we can see from the upper image, there is two CV curve. The first CV curve is from phosphoric acid PVA supercapacitor. The second one is sulfuric acid PVA supercapacitor. As we can see, the first one has high cyclic stability compared to the second one, but the second one has a higher specific capacity and energy density. From here, we can conclude that the higher the specific capacity and energy density, the lower the life cycle. The next finding is GCD curve of polyelectrolyte based gel polymer electrolyte supercapacitor for Alipori S 2019. As we can see from this GCD curve, there's triangular linear behavior. This can prove that it's consistent with the capacitive charge-discharge mechanism of the ideal double layer capacitor, which is the supercapacitor. It can be calculated from the GCD curve that the mass specific capacitance of the supercapacitor. The next slide is methodology. It's been separated into 5 phases. Phase 1 is preparation of electrolyte and electrode. For the electrolyte preparation, it's formed by solvent plus potassium iodide salt plus polymer PVA plus plasticizer. After that, the mixed solution will heat at 110 degrees Celsius and stir for 1 hour. Then the PVA based gel polymer electrolyte will be formed. For electrode preparation, it's prepared by reduced graphene oxide plus activated carbon plus binder plus solvent, and will become an electrode slurry. The electrode slurry will coated on copper foil and will heated in drying oven at 100 degrees Celsius for 12 hours, and the reduced graphene oxide electrode will be formed. Phase 2 will be characterized of electrolyte and electrodes. For PPA based gel polymer electrolyte, it will be characterized by EIS. For the reduced graphene oxide electrode, it will be characterized by XRD, Raman spectroscopy, and SEM. For phase 3 is fabrication of supercapacitor. Supercapacitor is fabricated from PVA based gel polymer electrolytes and reduced graphene oxide electrodes. For phase 4 is an electrochemical performance test on supercapacitor by CV and GCD. And the last phase is data interpretation and analysis. Next is the expected result. The expected result from phase 2, which is the characterizations of electrode and electrolyte, is high ionic conductivity of electrolytes by EIS, morphological characteristics of electrode clearly shown by SEM, proper structure characteristics of electrode shown in Raman spectroscopy and HRD. For expected result of phase 4, which is the electrochemical test, supercapacitor will have long life cycle and exhibit ideal double layer capacitor characteristics. So to summarize my PSM1 project, Chapter 1 contains a briefly introduction about supercapacitor electrolyte and objective need to achieve. For Chapter 2, it summarizes the literature from past researchers to support objectives. For Chapter 3, it lists out the working plan to solve the problem. That's all from me. Thank you. Thank you for watching.